part 1, which is the pump housing main body, Farisha and Iswafi were responsible for manufacturing the main body of the Peristaltic pump. Their tasks include preparing and measuring the raw material, performing the benzo cutting and lead machining, followed by drilling and M6 stepping according to the engineering drawing. They also carry out dimensional inspection to ensure the component met the required specification. For part 2, which is the roller holder, Darwish and Wan were responsible for fabricating the component. I would like to explain the safety equipment and safety techniques followed throughout our workshop project. Before starting any machining operation, every group members were required to wear the appropriate personal protective equipment or PPE. The required PPE include safety glass to protect our eyes from flying chips and sparks, a fully zipped workshop jacket to prevent loose clothing from being caught in the machining, and safety shoes to protect our feet from falling objects. Ear protection was also used whenever the noise level was high.
During the gliding process and when handling sharp workpiece, protective gloves were worn to protect our hands from sharp edges, heat, and sparks. However, gloves were not worn while operating rotating machines such as the lathe, milling, or drilling machine because they may become caught in the rotating parts and cause serious injuries. We also provide proper workshop safety throughout the fabrication process. Before using any machine, we inspected its condition and ensured that the workpiece was securely clamped. Female students keep their hijab neatly tucked inside the workshop jacket, while all jewelry and accessories such as watches and rings were removed before operating a unit.
First day was surface cleaning. The raw steel workpiece contained rust or in outer surface. Therefore, the rust were removed before machining to obtain a clean surface, improve chuck gripping, and ensure better machining accuracy during the following operation. After cleaning the workpiece, the facing operation was carried out using the lathe machine. This process produced a flat and smooth reference surface before the subsequent machining operation. Next, center drilling was performed to create a guide hole, ensuring accurate alignment for the following machining operation. Next, boring was carried out to enlarge the pilot hole to the required size while improving the accuracy of the internal hole. Next, a twist drill was used to enlarge the hole before the final boring operation. Next, final boring was performed to achieve the required internal diameter and improve the surface finish. Next, internal resistance boring was carried out to produce the required internal resistance with the specific depth and diameter. The workpiece was separated from the raw material using a hacksaw before proceeding to the next machining process. Next, grinding was performed to smooth the cut surface and remove any burrs. Tapping was performed to produce internal threads according to the required specification for assembly. The side holes were drilled using a drill press according to the required dimension after the tapping process. The rear hole was enlarged using a boring tool to achieve the required diameter according to the engineering drawing. Two side holes were drilled using a milling machine according to the engineering drawing.
Next, while the other team is fabricated for the part 1, my partner Darwish and I, Zairil, took a full charge of the manufacturing cycle for part 2, managing everything from the raw steel plate to a final fitting.
Step 1. Plate cutting. We measured and marked out the exact blueprint coordinates onto our milled steel plate. The piece was then securely clamped and cut to size using the horizontal bandsaw machine.
For step 2, initial grinding. For the post cutting, the raw edges carried a heavy metal burrs, so we ran the piece through a grinding machine to smooth the surface and square up the sides.
Step 3. Hole drilling. Next, we apply a center punch to create a precise guide mark, preventing the drill bit from wandering. We then shifted to the drill press to execute the core holes.
Next, for step 4, profile shaping. Using the grinder, we carefully shape down the plate contours to match the exact geometry profile of the part 2, doing a constant dimension check to stay within the tolerance.
Step 5. Hand tapping for the internal threading. We manually operated an M6 hand tap set. We rotated the tool 2 turns forward and half a turn backward to clear metal chips clearly.
And so last but not least, step 6, which is the finishing. So lastly, we perform a surface finishing using the grinder to strip away any surface oxidation or any minor scratches, leaving a clean and rust resistant surface.
The first problem that occurred to us is we accidentally dropped the metal pieces onto the ground and it causes a dent towards it. So how do we fix it? We grind it to hotten up the metal, and then after that we took a center punch and we hammer it down so the dent's been pushed out again to its original position. The second problem that occurs is keeping the metal clean. We have to constantly grind it to keep the finishing smooth and very clean. The third problem that occurred to us is that we couldn't fit the bearing in the first place. After we boring it to widen the hole, we still couldn't fit it, and we decided that we just use center punch and hammer it down, and then it become fit and it become perfectly suited for it. The last problem that occurred to us is that the screw holder that we built is very small, so that we couldn't clean it using a grinder, so we have to think creatively, and we decided to use milling for surface finishing, since milling are very precise and it can cut off in small amount of quantity.
And last but not least, for our improvement, so to improve our dimensional accuracy, we found that sometimes relying solely on manual grinding led to a slight variation in the component final radius. So to achieve the strict geometric tolerance for the peristaltic pump, we should utilize a CNC milling machine rather than the hand grinding. So using programming the profile by using the CNC machine will guarantee 100% repeatability, perfect smooth radius edge, and also a flawless consistency across all the fabricated part. For the second one, we can observe that the rapid surface oxidation and corrosion is happening on our steel component. So because we store the raw fabricated part inside just a standard cloth bag, we left it highly vulnerable to the atmospheric moisture, sweat, or maybe accidental water exposure in the workshop environment. And then to avoid this material degradation, the future component should be immediately treated with like a thin layer of anti-rust oil, or maybe the storage must be upgraded to a airtight container with a silica gel pack to absorb the humidity. And then for long-term durability, we can apply a professional powder coating or zinc plating surface treatment, where it can provide the peristaltic pump with a robust, water-resistant protective barrier.